starting the workshop on hazard identification using HAZOP, and it will be chaired by Dr. Viswanathan. He is the former Deputy General Manager of Indian Petrochemicals Corporation, RIL Vadodara. He has more than 3 decades of operation and technical services experience in petrochemicals, in IPCL and synthetic fiber in plants. He has also acquired engineering and HSE experience for 10 years while working with LNT, Chioda, and Technip, along with his associations as a risk and safety consultant with German Nischer, Lloyd, and MS Chola Risk Services on HAZOP, HAZARD, SIL, and other safety studies. He has about 10 years of experience in handling highly toxic acetonitrile plant that produces lethal hydrogen cyanide as a byproduct. Shri Viswanathan is currently associated with Tibetan Middle East as an associate principal consultant. Please welcome Dr. Viswanathan, and he will start the workshop.
Good evening, everybody. Okay, she has told something about my introduction. More than anything else, I just wanted to share one important thing. Whenever an industry started, the industry is own pitfalls, and it affects the people who work around, the operators, the supervisors. It works also to cause harm to the people working in the nearby areas. That is environmental impact of that, any mishap is happening in the factory. The third one, if there is any mishap, the factory loses equipment or many more equipment, and it causes a lot of asset loss. And of course, you get a bad name because a lot of, the TV, newspapers, they happened there, it happened there, it happened there. So you get into all the problems. Okay. So basically, people have to be very careful whenever we are running an industry. Okay. And they have to take care of all these things which are likely to happen in the process. Okay. Incidentally, as she mentioned, I was working in one of the plants in IPCL at the time. I was working in one of the plants in IPCL where it was producing acrylonitrile. The acrylonitrile had a byproduct, hydrogen cyanide. This we are producing almost 1/10 of the whole production of acrylonitrile. We are producing hydrogen cyanide. It is much more lethal than methyl isocyanate of Bhopal. You are all aware about the Bhopal gas tragedy, where many people have died, many people have lost their lives. The plant where I worked, I was a senior production manager of this plant for 10 years in IPCL. And I was holding the lives of all the people of Baroda for 10 years in my hands. In my hands means in my heart. Because anything which happens to that plant in that area, any leak or any major leak can be highly fatal. So that is the background which I wanted to just share. And before we go into this, that's why all of you people who are all interested in sitting and listening to this, because normally I conduct a 2-day workshop on this HAZOP, but this particular one is a short session. So I'll be only touching upon the major issues. Most of it you may be aware, but still I would like to touch upon those issues which you must take care. If you are already taking care, it's good. Or if you want to be this one, you can add a little more here. Okay, we are going to cover about the various hazards and risk. What is it? Risk management principles and personal protection equipment and their usage. This is one which is the basic need of that, this one. We call it as, which see there are two types of safety. One is the process safety. Other one is the personal safety. The personal safety is the one which takes care of the personal protective equipment like the helmets, goggles, hand gloves, shoes. These are all personal protective equipment. It protects only you, doesn't protect anybody else. Whereas the process safety covers the whole gamut of safety. That means it takes care of the people, assets, everything it takes care. If you look at this, is a tiger in a forest. Nobody goes nearby that. They can see it only in a picture. But if you go nearby, it's a man eater. It will simply kill. The same tiger is now in a cage. Once in a cage, including small kids, they go and play with that. Okay. They want to get that fellow, irritated and then something like that. So here, because the cage is there, they are sure the tiger cannot come out. That is the reason this tiger inside the cave is one which is taken care by this cage is the protective barrier. You got the point? This is most important thing. We are working on the protective barriers which will be able to protect us from any harm in the plant also. So here, as you may be all aware, hazard means one which can cause a harm to people or illness. This is the illness means, any exposure to chemicals, it leads to sort of, people start with a cough and then it goes into a fever and then it goes into much bigger cancer sometimes. Okay. So this is the one which can cause illness at a longer date. Injury means one which can really happen, you just go and get your finger cut, you get your finger crushed. These are all personal injuries. These are small things. But this is the one, whatever actions we do it, it has a potential to cause harm or illness. This is what we have to look at. What is it we are doing it? Is it going to cause us harm or is it going to cause us long-term illness? This is what is the one which is to be looked at. So that is why any activity, procedure, plans, process, substance, situation, or other circumstance that has the potential to cause harm to people, environment as such, plant facility. This is what is called a hazard. Okay, this is the definition of that. So what we are trying to look at, we are not looking at the hazard. We are looking at the risk in all the plant operations or the processes. We are looking at only the risk which are involved. Risk has got two dimensions. One is the potential to cause harm. We call it as a severity. And the other one is the probability, how it can happen, how soon it can happen. Can it happen every day? Can it happen once in 10 years? Can it happen once in 10 months? That is the probability of the risk, which can, the severity which can be caused and which will result in risk. So the risk is a function of both probability as well as the severity. Okay. So risk is defined as the probability that as a substance or situation will produce harm under specific condition. This is the one. And risk is a combination of two factors I mentioned about it. And the probability that an adverse event will occur, that is what is the main thing, probability. So the consequence of adverse event is what is that. That is why the risk is defined as the probability into severity. This is what is the expressed form of risk. We are trying to look at only risk. We are not looking at only the harm. Okay. So that is why this hazard is something that can cause harm. The electricity, chemicals working up ladder, noise, etc. Risk is the chance, high or low, that any hazard will actually cause somebody harm. For example, the electric cabling is a hazard. If it is damaged, the exposed wiring place, okay, it is at a high risk category. If anybody touches the 240 volts or 500 volts, this one, you will die. Okay, that is why hazard, anything that can cause harm, that example, chemical, electricity, ladder, etc. This risk is how great the chance that someone will be harmed by the hazard. That is what is important. The hazard is here in this case the damage electric cable. That is one example. Okay, so that we have to ultimately look at what is going to be the likely risk if that is exposed cable is touched. That is why it is to be always seen like this. And then ultimately, that could be a fatality. It's called high risk category. Okay, this is what we already seen it. Okay, mainly here, if you look at it, if you look at the x-axis, the probability, severity is of harm, and the y-axis is probability. If you look at that, the top one is high risk. Okay, the top one is high risk. And the green one here is low risk. We have to really see that we have to bring down all these things to the level of low risk. If not possible, in these lines, between these lines, this is the line which is called as low as reasonably practical. We call it as alarm. We have to bring it below that line. If this band is used, then we are reasonably safe. That's why I say that the line of risk, these two are lines of risk. The process risk is always the highest risk is at the top, the lowest risk is at the bottom, and in between is the safest area. This is only to just to give you a pictorial vision of how the risk is defined in terms of severity as well as probability. Okay, if you take all these activities, like a smoking, it can cause so many this one per year, per million per year, PY. Drinking alcohol, swimming, traveling by car, traveling by train, traveling by aeroplane, all the activities has got an inherent risk, all these things. Only thing, the degree varies. Something like, traveling by aeroplane, it is only 10 PMPY. Whereas smoking is the highest, 5,000. No problem. No, it's okay. It's okay. So with this type of a thing, we will have to see, even if these are all activities which are all taken care by normal working. It is not a factory working. It is day-to-day working of people, going by car, going by train, drinking alcohol. These are normal activities. This itself has got so much of a risk. Okay. What we are looking at risk reduction. As I mentioned about that previous slide, here we have to bring down the risk from that red one to the green one. The people here sitting, they are happily enjoying their beach, this one. Whereas if you look at it, the top one is all, that is it has gone on flame. This accident has taken place. And so the consequences could be the highest one once you move from left to right. Okay. And the same way the hazard rate goes from bottom to top. So we have to come down from risk without any protection. If you don't have any protection layer, as I mentioned about the tiger, this one, if you have a cage, you are protected. If you don't have a cage, tiger will kill you. Like that, the more the layers of protection you have it, your risk is reduced and you will be able to live happily. This is one which I made for somebody else. And, it's for college students, they wanted to have some sort of this one. If you look at it, 6 two-wheeler riders die every hour in road accident. This is the data. And you can just look at it. The Amaraja is just going after that fellow because he doesn't have a helmet. So correct helmet use could reduce the risk of fatal injuries by 42% and head injuries by 69%. This is the World Health Organization's data. The principle behind this, if you are able to protect yourself, you are able to save yourself. If not, Amaraja is waiting for you. So these are the personal protective equipment like, protective clothing, helmets, gloves, face shields, goggles, face masks, respirators, or all these things are supposed to protect individuals. It is not supposed to protect the society. So this is one, I got a, sorry. That is that boy. I just gone. I wanted to just run that. There is a video here. I love all that fellow. Oh boy, somebody has to come here with me. Somebody should sit here. I don't want people to go away. Otherwise, things will stop. I want to run that video. There is a video here. How to run this video? Can you help me? This video, there is a video here. this particular one tells even when you're working, you know, you can have this type of accidents, and you have to protect yourself with all knowledge. Okay. Then this is what will be the one which will be happening if you have that, if you don't take care. Okay. So anything can happen. You know, like this man goes below, that one top one sling snaps, and he has got a helmet. So he will get protected. His head is protected, but then there is this one has got damaged. If he doesn't have the helmet, he will have head injury. So there are 6 steps to take for risk management. The first step, identify the hazard. What can happen? You are first to do that job. That is the first principle in identifying the hazard. Then identify the risk. It is the potential consequence of hazard. That means, is it a high risk or low risk, depending on the severity? Can it cause me a small injury, or can it be fatal? The third one is assess the risk, identify the severity of probability, that is likelihood. This is what is important. If you are able to assess the likelihood, then if it is not a severe probability, is a very minor one, once in 10 years, so it may not happen. So you have got a better protection. So control the risk by using safeguards such as engineering control, use of PPEs, etc. These are the safeguards which I mentioned about the barriers, like the case of the Tiger one. They document the process, monitor, review, effectiveness, safeguard. These are the various ways, yes, safety, this one can be taken care with respect to risk management. So this is the one, normally every company should have this type of a risk matrix. This is a very important thing. If you don't have it, please make it. Because this risk matrix, if you look at it, the severity rating right from minor injury to multiple fatalities. Okay. That could be 3, 4, 5, many people can die. Okay. There could be a small one, the treatment with requiring medical treatment, short-term health effect, last working day injury, medium-term health effect, major injury, like that single fatality, multiple fatality. These are the various things can cause harm to the people. Like that, it talks about the assets loss, minimum damage, slight damage. It can be in terms of 10 lakh, 20 lakh, it can be 50 lakh, 100 lakh, 1 crore, 10 crores. So this is the various ways. The environment, it can cause a small effect, and there could be because without pollution control board, the control boards are there. Every state control board will take care of that emissions from the factories. That is what is the thing taken care about environment. The reputation, as I mentioned, it can go to the press. It can cause harm to the company's image. So these are the various ways that this risk matrix is made for a company, and all the red ones are dangerous things. They have to be brought down either to yellow or to green. If you look at this is the one which you should people keep in mind. If you look at the likelihood, the one is 10 power minus 1. That means it happens once in 10 years. Next one, 10 power, that is once in 10 years to 100 years. D is 100 to 1000. This is 1000 to 10,000. This 10,000 to a lakh. A lakh to 10 lakhs. This is the grade in which the likelihood is plotted. Okay. This is what every company should have this type of a matrix. Then only they will be able to know where we are, what is the company's acceptable limit. They will say, we can accept a fatality of 1 fatality in 100 years, 10 years. So that is what the company will tell, based on which you have to really see that it is taken care. So this is what I just wanted to give you introduction about the hazard. What is the hazard? What is the risk? What is the severity? What is the probability, based on which we will be able to really move to the next one. How do we go to the next session? Call him that. See, that man has to sit here. He cannot go away. It's a problem, So evening time means everybody wants to go away. Nobody wants to stay here. It's a useless thing. The same thing, I have to go back to that, why you be here, yeah? I told you, no, don't go away. There is the next one, we have to go to the next slide. Please don't go away. Second part. Please sit here. This is Manchester. Yes, Manchester. Manchester. Okay. Yeah. Okay. This one, if you see that, like the cage I mentioned about the tiger, this is depicted as a classic species model. Here if you look at it, the left hand side you have got the hazard, okay, and the right hand side you have got the harm. If these are the protective barriers, if you are able to strengthen these barriers, that means if the holes are not matching, that means it will go one and then there is a block. And third one, there is a hole, but then there is next one, there is a block. If these are the things, the protective barriers are all in act available, then you don't have the harm. If they are not there, if they fail, then the harm is there. That's a weakness or holes. Once the holes are aligned, then this will harm will pass through and will come to the result in harm. That is what is the principle you should understand. The same thing, this is a very classic Swiss cheese model. In Switzerland, the cheese is made in a block which has got this type of holes. That's why they have chosen this. And this is a very classic example of safety, this and how the barriers really work. Okay. Yeah, please. Thank you. After this is the hazard from your line. Here, left hand side, you can just see the line sitting there. The same thing, the threat, human error. Suppose we do anything improper cage or design, some problem is there with the cage, the line can escape and then kill the fellow. Control barrier, that is material of concern. That means zookeeper, he takes rounds. He says that this cage is intact. Okay, the top event, loss of control, client gets out. And then recovery measures, zoo emergency response plan, these are all available. The consequence is the fellow is killed. So injuries or fatality, this is what will happen. Here, this is the hazard. And here is the harm. When all these things fail, finally this will happen. That's why just, this is what people should keep in mind whenever we do any job. Is it going to cause this? If it is going to cause this, what are the things we can take care? How to prevent that? So this is the same thing, which is also for a small road ag transportation. Mechanical failure of that, and then design, instrument warning devices, and then loss of control. There are various things, and then vehicle, how that safety is taken care. And then ultimately this training, and then finally collision injury. If that is not properly trained, that's why they give the learners driving license. Then only they give the final license after all the tests are conducted and confirmed. So that this is what is the way. Yeah, hazard can happen from collision injury, because it can go and hit a truck. The fellows will die. So this other one is, there is an exposure of the chemicals like hydrogen sulfide. If it comes out, then it can cause harm to the people. It can come out because of overpressure. There is a vessel containing hydrogen sulfide along with something else. If there is any pressure comes up above the design pressure, it will come out. Then the inspection, this is also taking care that it happens, it doesn't cross the design pressure. It is within that pressure control. And if anything happens like that, the safety valve will open and go to the atmosphere. It will not cause harm to the people. That is why these are the preventive layers which takes care of that. And then there are alarms, sensor alarms are there, which can take that there is a hydrogen sulfide leak is there. The emergency response procedures are available. So to prevent the injury, if these things are all in green, if they are taken care, that injury will not take place. Now we'll come to the various hazard identification techniques. There are various methods are there. The checklist is one, where questions to assess the hazard identification. Then brainstorming, we have a discussion with everybody and then find out a group of people, amount knowledgeable, they discuss that. And then what if analysis, if somebody asks, if suppose what will happen if the pressure goes high? What will happen if the pressure flow rate goes up? What if? These are the various ways questions are asked and possible outcomes are all defined. That is called FMEA's failure mode effect analysis. These are the different type of techniques for mechanical equipments. The task analysis, this is maintenance activities, procedures, these are all tasks. Fault tree analysis. The fault tree tells about how the tree is built up depending on each fault. If one failure is there, what will happen next stage? If that failure takes place, what will happen next stage? It comes to a top event. So we are going to look at HAZOP. It identifies process plant type of incidents. This is the one which is relevant to the process plants. And we are only going to talk about that, not all other things. Okay, if you talk about HAZOP, it's how many people have attended HAZOP sessions? People are all aware of how many people? Yeah, he knows about it, I know. Okay, don't bother. HAZOP is normally conducted either for a running plant or for a new plant. It can be done for anything. Right now, I am busy. I have already done in that, you have got YNGC petro additions in Dahej. They've got a petrochemical plant. The cracker is there. They are producing ethylene, propylene, butadiene, all the things. I have already completed their HDP, high density polyethylene plant I have completed. I am in the midst of completing that polypropylene plant. Tomorrow morning again, in 7 days I have done it. Tomorrow morning again, I'm going to Dahej. We'll reach by 10 o'clock. We'll start the session on the 8th day. And like that, this is the thing which is already happening in the running plant. A plant which is already operational for 5 years. That plant, they want to recheck whether the things what is already given by their licensor, designer, are they working. And second thing, as you're all aware, there could be some changes that are needed. You add some more equipment, you remove a valve, you put a new valve. So many things are done in the plant over a period of time. And every activity which is going to change the existing design, you should do HAZOP. The implication of that change, suppose you give a bypass line, what is going to happen if the bypass line works or if the valve fails? So all these things you have to identify the safeguards are available. If suppose something happens, is there an alarm to tell? Yes, the pressure is going to go high. Yes, pressure transmitter will be there. It will give a high alarm. The operator will go and immediately depressurize it, either by draining the things or venting it out, whatever it is. What I'm trying to say, these type of things are all done for either existing plant or a new plant. That is why HAZOP is a fundamental thing which people should take care, because this is the one which will be able to really protect people, assets, environment, and the goodwill of the company. And what happens, as you're all aware, a plant means a very big issue. This one, there will be having so many sections, so many equipment, there will be hundreds of equipment. Okay, so each equipment, we call it a specific systems consisting of equipment with associated pipelines are considered for evaluation design. We take it by equipment, along with a pump, a tank, a pipeline, which goes to the next one. We call it as a node. Like that, if there are small nodes, if you have it, there will be about 100, 200 nodes. When you will complete the plant total HAZOP, you add some 5 equipment, 6 equipment, and then make it as a node and try to make it in the whole design. For HDP plant, which I had about 104 P&IDs, all of you may be aware about the process instrument, piping instrumentation diagram. This is the basic thing on which we do the HAZOP. And we try to mark the nodes by color, different colors to identify. And after identifying that, we try to evaluate what are the risks involved in each thing. And there are various things I will tell now. And based on that, once we complete, we go to the next one. Then we go to the next one. Like that, we complete for the whole plant. That means there could be 10 nodes, 15 nodes. For the HDP plant, which I did, there were 32 nodes, I think. And here, this plant will have about 32 nodes around. So this particular one is the total plant list broken into so many nodes, and then the evaluation is done. So it's a team exercise. There will be people from the operation. There will be people from technical services who knows about the process conditions and who will be able to support. There will be people from instrumentation. There will be people from mechanical. There will be so many other people who will be able to really contribute for during the discussion. They will say, no, this is not happened. This is going to happen. Take care. So these type of discussions will be taking place in the HAZOP session. And there will be a chairman who will be looking at all these things and then listening to that. And he will evaluate whether anybody who suggests that this can happen, whether he will say, is it credible? Is it likely to happen? If it's likely to happen, yes, safeguards are to be seen. If it is not likely to happen, let us not do it. Okay? Because if you want to do that, the best plant, you can make it by gold. It's very costly. You have to make it by mild steel or carbon steel or stainless steel. You have to just decide. So it's a structured brainstorming to look for deviations from the design intent. That's what is most important. The designer gives you a plant with a design intent. That means this is my flow rate, this is my temperature control, this is my pressure control, this is what is the thing which can give you a product of this quality. Any deviation within that parameters of flow, temperature, pressure, or any such level, everything can contribute for a deviation. Once the deviation happens, what can be the thing which can result? Is there a likelihood of any hazard? Is there likelihood of any harm? If that is there, how that can be protected? That is the purpose of HAZOP. So this I told you. Essentially, the HAZOP procedure involves taking a full description of the process and systematically questioning every part of it to establish how deviation from design intent can arise. This is what is important. Once identified, an assessment is made as to whether such deviation and the consequences can have a negative effect upon the safe and efficient operation of the plant. If the evaluation really tells you there is going to be a high pressure, if the high pressure is there, whether there can be a leak or the vessel can rupture, because they're all designed as per the codes, API codes, ASME codes, but still the vessel can rupture. So these are the things which are all done by the team, and then they come to a conclusion. If considered necessary, action is then taken to remedy the situation. What is the remedy of the situation? If there is a high pressure, give an alarm. If the alarm is not there, give a high pressure alarm. The moment the pressure goes to that, you will get an alarm. Oh, the pressure has gone in that. What has happened? Why this alarm is coming? Something has got choked. Open that vent and then clean it. So that, this is the way the whole HAZOP process goes. So these are various parameters in that process, like flow. Okay. Flow through a pump, flow through a vessel, all this pressure, and then temperature, level, composition, reaction, reduce. These are all the things on batch process also. Corrosion, drain, vent, inspect, startup. So all these things, these are the various things on which we evaluate each and every node. Every part of the node, the deviations are all, these parameters are all applied and then evaluated. And the parameters, and these are the guide words. We call it as guide words. No. Then we'll have say the no means the design intent does not occur. Flow, no, that means there is no flow. If there is no flow, mean the pump stops, no flow is there. Like that, what is these guide words are going to be the one which is going to help. No and less can happen less. A quantity decrease in the design intent occurs, and then it comes with more. It can come with more flow or more temperature, all these things. And it can happen with reverse. The flow which can go up, it can come back. By something else is blocked there, it can flow back. And if the check valve is not working, it will flow back. No reverse flow. Okay. Then also something will happen. This also will happen. That flow also will happen. So these are the various guide words which are all used for the HAZOP. And the potential deviation, we call it as the parameter like flow, temperature, pressure, and the guide word no, less, more. All these two, once you combine, then that comes to a result in potential deviation. This is what we are interested in to analyze. Okay. Example, flow, no. Okay. No flow. Suppose if there is no flow of a particular stream A, what is going to happen? Is going to have any problem? The safeguards are available? Yes. Is it sufficient? Yes. Then go further. Sorry, like that level, high level, high. Sorry, yeah. Yeah, please. Okay. Now, if you have anything, don't bother. Ask me. No problem. So, the main issue here is the priority for safeguards. You know, there are safeguards available. You can go on suggesting so many safeguards. But first of all, the elimination of the cause is the first one. If it is going to cause high pressure, eliminate that cause. Okay. If you look at it, those technologies which are about 40, 50 years back, I was working in IPCL. We had a low density polyethylene plant. You know the pressure of that low density polyethylene process? 5,000 bar. Imagine the pressure, 5,000 kgs per centimeter square gauge. That is the reaction pressure of ethylene to make polyethylene. Today, the pressure, same this one polyethylene is made out of 15 kg pressure, 1.5. How? The technology improvement. Okay. That is why this, they know if the pressure goes high, it can cause harm. So they have made this one by which they brought down the level by reducing the pressure. They have increased the catalyst. They increased the reaction time, something like that. They made some changes in the process design by which they were able to really eliminate the cause. The cause is the high pressure. And consequent mitigation, that is a consequent mitigation is something which is how do you prevent it? That doesn't help you. You have to eliminate the cause first, if possible. That is why it is called inherently safe design. Nowadays, the present concept is inherently safe design. That means you don't store. You know what has happened in Bhopal? There was a storage of 40 metric tons of methyl isocyanate in the plant, which was really not needed. Had they stored only 4 tons, that fatality would not have been this much. So that is why today, the concept of inherently safe design, don't store more than what you need. If there is a step which is needed for 1 day, use it only for 1 day. You get a tanker, get it in 3 days, something like that. You don't store so much of raw material which can cause harm. Same way, don't store so much of product which can cause harm. If there is a product which is made already, send it out of the factory. Okay. There are various concepts which are used because everybody thinks about what can happen to me, what can happen to my people working around me. This is very important. That's why inherent design question, that's what I mentioned about. So then there are written procedures that are available. We call it as SOP, standard operating procedures, and that we use it operations and maintenance procedures are there, inspection procedures are there, testing procedures are there. These all will be able to help you with respect to the control measures. Then training, people's training. Then history. Suppose if there is anything which has happened in one plant, use that in history so that it doesn't happen into your plant. Okay. This is what is called previous lack of it. Equipment inspection. clean or non-corrosive service. Because these are the things you'll be able to really tell you what can happen, when can it happen, how it can happen, prevent it. So equipments are taken care by safety valves. Okay. Written voting system. There are also, sensors. Sometimes you have 3 transmitters, like, there will be 3 temperature transmitters. So if there is a failure of 2 transmitters, then only that will really say there is a failure. With 1 transmitter failure, they will not accept it. That's why the voting system will be able to take care of that. Redundant means if there is one transmitter failed, the other transmitter is available, that will work. Okay, these are the things. Independent alarms shut down. Same way, alarms. If there is anything which is going outside the control, then the alarms will be able to caution you. And DCS operator will be able to take action. Shut down, control instrumentation. These are the various ways the equipments are protected. So this inherently safe design, okay, substitute replacing one metal with another that is less hazardous. This is what is the main thing. Nowadays, in this MIC production, previously they were using carbonyl. Now that is now replaced by different product, raw material. Okay. Previously they were using carbon monoxide to make that. Now it is all changed. Process is changed. Like that, you substitute by replacing the material which is less harmful. Previously they were using hydrochloric acid for making linear alkyl benzene, which is used in soap, that has been now replaced by sulfuric acid. Hydrogen fluoride, if it comes, drop also falls on your body. It can eat your bone. It will drop, it will make a hole inside and come out. That is the property of hydrogen fluoride, hydrofluoric acid. Whereas HCl or hydrogen sulfuric acid doesn't have that. It also causes burn, but it doesn't cause that harm of eating the bone. So that technology is changed by substituting a less hazardous, less harmful chemical. Minimize, as I mentioned, then it is minimized. Then moderate, using less hazardous percent, like low pressure. I mentioned about the LDP process. Simplify. If you can simplify, because don't complicate, make it as simple as possible. Then, then this process will be able to take care. And that is why this has to be discussed. And then that's why brainstorming is important. People who are knowledgeable, people who can see many things. One man cannot decide. I have some approach, I have some knowledge, but my knowledge is not sufficient. There should be some 10 people equally knowledgeable or less knowledgeable, doesn't matter, but they will be able to have some experience. Knowledge is different, experience is different. Some operator may be there, he will say, "Saab, ye karne ka zaruri nahi, sir." Listen to them. Evaluate. Don't say, don't accept, but evaluate. So this second thing, HAZOP, as I told you, it is a team activity. So team members are there. So team chairman is a facilitator. Then the scribe, a person who will record all these things in that worksheet. Okay, we call it as a worksheet. And then the process lead, engineer from engineering company. There could be a designer. This company process lead may be there. And then instrumentation engineer from the engineering company will be there. Who can substitute. You can say that this alarm I already given. There is no need for one more alarm. Otherwise, you'll be adding extra cost. The project manager from engineering company will be there, who has done the project. The operation manager, engineer from owner, the person who has been running the plant, he'll be there. He can help you. Instrument engineer from owner, that man will be able to tell based on his operation experience, he will tell this will not work. HSC representative from owner, because the health, safety, environment, every company should have one representative. He should try to evaluate what could happen and he will be able to. So these are the type of people. If you say here itself, there are about 78 people are there. I have worked with people about 14 to 15 people. And sometimes in Middle East, even 30 people are there. Okay. So process engineer from licensor. Oh, instrument engineer from licensor. There are so many people, It can be, team can be as big as 30, 20, but more the team, more confusion. Less the team members, knowledgeable, you'll be able to have a good output. Okay. So then, the facilities in our meeting room should be the designated room for free discussion from disturbance. Nobody should disturb. Okay. And overhead projector, preferably 2 in number. Okay. Software loaded laptop with this so that scribe can really record all the proceedings. and then flip charts with pens, so where people can explain what are the things can happen in the flip chart. Okay. Then meeting notepads with pens participant. These are the things that are all needed for the meeting. Documents for each participant. See, main issue is the plant process description. All of you may be aware, every plant is written with a process description of the whole process, starting from section 1 to section last. Okay. And everywhere they write about what can happen, everything. They write the sequence of events. The flow starts from pump A. It goes with like that. It goes to tank like that. These are all things. Process description document is one. Then it comes to process flow diagram. Next level. The same process which is written is shown in a diagram. That's called process flow diagram. Okay. Then comes the piping and instrumentation diagram. That is the next level, which gives you all details about your process, control valves, instrumentation. Everything is given in that P&ID. Okay. And after that P&ID, it also comes with the safeguards. And say like that, control narratives are there, interlocks are there, trips can be there, alarms can be there. It's all the description, all the documents. If you have it, somebody can say, no, there is already a trip given. Why you want to give one more trip? No trip is given. So we should try to give a trip. This can happen. It can be much more fatal. Severity can be high. Let us have one more trip. So these are the ways that HAZOP sessions run. The P&IDs with node markup on walls. So tea, coffee, snacks, because it's HAZOP is a very strenuous process. We normally have a break after every 1 hour and 15 minutes or 45 minutes, depending on the type of people's mood. Once I see people are all not interested, I said, okay, let us have a coffee. That's all. All people walk out. The reason is, this is a brain-related job. You cannot just simply use it like that for 8 hours. No, it's not possible. You have to have a break. So this is a simple example. This is why I said, let me start with a simple example. This is a dosing tank. There is a strainer or a filter, you can call. There is a pump. Then there is a mixer where the chemicals mix from there. Somewhere some other mixed chemical comes. The pump pumps it, and then it goes to a reactor. If you take this as a node, how this is operated, I am just trying to explain. Deviation. The keyword combination being applied is example flow no. Suppose if there is no flow, this is the word we want to use, that deviation of no flow. Okay. How that will happen? The potential cause which should result in the deviation occurring, it can be strainer blockage. The strainer chokes, no flow will be there. That's why that is one reason. And it might be a cause for no flow. Okay. The consequence which would rise both from the effect of the deviation, loss of dosing results in reaction upset reactor, and if appropriate from the cause itself, the cavitation of the pump. Pump also will cavitate. There is no flow. Okay. It will possible damage the prolonged. If it runs, the impeller will go. So these are the consequences. There is a damage of the asset, that is with respect to pump impeller. You have to replace the pump. Okay. Like that, these are the things, consequences are all evaluated. The safeguard. Any existing protective device which either prevent the cause or safeguard against the adverse consequence would be recorded in this column. Okay. For example, you may consider recording local pressure gauge in discharge from pump might indicate problem was arising. Okay. Did you see that there is a there is a PI is that the pressure indicator is there, which indicates that pressure is low. When the pressure is not showing, that means it's not pumping. So this PI is indicating that there is no flow. Got the point? This is like that. The instrumentation which is given for the whole process will be able to guide you what is available as a safeguard. Okay, now, okay, next one. Note the safeguard need to be restricted to hardware where appropriate. Credit can be taken for procedural aspects such as regular plant inspection if you are sure that will actually be carried out. Operator monitoring. Field operator goes and checks whether the pressure indicator is showing correctly or not. That is what is the meaning, that the pressure indicator is just dead. Nothing is shown. That means the pump is down. So you'll see, go and start the new standby pump, something like that. Okay. So recommended action. Action falls into two groups. Action that removes the cause. That is what is the first important thing. Action that mitigate, eliminate the consequence. These are the second one. So this can be recorded in the sheet of HAZOP. Is it okay? Yeah. Please stop me whenever you want to stop me. Tell me. So always investigate removing the cause first, and anywhere only where necessary mitigate the consequence. This is the most important thing. Example, strainer blockage due to impurities, etc. We might approach the problem in a number of ways. How? Ensure the impurities cannot get into tank, fitting a strainer in the road tanker offloading line. What is coming from the tanker? You see that there is a filter or a strainer put in that this one, so that the impurities doesn't get into your system. This is one method of eliminating it. Consider carefully whether a strainer is required in the suction of the pump. Will particulate matter pass through the pump without causing any damage? And it is necessary to ensure that no such matter gets into the reactor. If we can dispense with the strainer altogether, we have removed the cause of the problem. You got the point? The strainer is supposed to take care of the impurities. If you are able to prevent the impurities right from the tanker itself, it will not come here. Yeah, already eliminated the cause. These are various ways. Fit a differential pressure gauge across the strainer with perhaps a high DP alarm to give clear indicator that total blockage is imminent. If you put a filter and if you put a pressure gauge before, pressure gauge after, and if you measure the differential pressure, if the discharge is blocked, totally strainer is blocked, their outlet pressure will be not showing at all. The pressure drop will be very high. If normal flow is there, whatever flow is there, it will go through and then the pressure drop will be less. When the pressure drop goes high, that means filter is choked. Fit a duplex strainer with a regular schedule of changeover and cleaning the standby. Normally what happens, they always put two strainers. One, when it gets blocked, they bypass it, they take the other one on the line, take out the blocked one, clean it, fit it back to be ready for the next operation. Like that, these are various ways of doing it. So there is an example for a batch reactor like that. Here you look at it, cooling water is flowing into this reactor. Temperature control is there, thermocouple is there. Cooling water is going through the coil and then coming out. The feed is there, is a chemical which is coming in, and which is a reactor is running with the agitator. Reactor control. So the reaction is exothermic. A cooling system is required to remove the excess energy of reaction. In the event of cooling function is lost, the temperature of the reactor would increase, isn't it? If there is an exothermic reaction and if there is no cooling of this reactor and this one, then the temperature will rise. This would lead to an increase in reaction rate, leading to additional energy release. Because the reaction rates are always favored by higher temperature. More the temperature, faster the rate. Okay. The result could be a runaway reaction with the pressure exceeding the bursting pressure of the reactor. The temperature within the reactor is measured and is used to control the cooling water flow rate by valve. Okay. If this reactor pressure goes up, it can burst. Normally, they would have provided safety valve so that the pressure doesn't burst. Safety valve will open it out, but still you lose the material. So, but that is taken care only by a cooling water flow. If the cooling water flow is there, if the valves are working properly, your temperature control will be effective. So, this, if you look at that, the same thing, if you look at as a, this is the way the HAZOP worksheet is made. Guide word, deviation, cause, consequence, action. No cooling, temperature increase in reactor. Got the point? Reverse flow, reverse cooling, failure of water source resulting in backward flow. More cooling flow, instruct operator to, these are the things which are all normally recorded like that. But this is not sufficient. This is the answer for that. No cooling. So what can be the cause? The cooling water valve can malfunction. It doesn't open. If you got a control valve, the control valve will fail and it will not open. So that valve is closed. So cooling water valve malfunction. That is the cause for that problem. And action, install high temperature alarm. The moment that this one goes up like that, cooling water is not that, temperature goes up. So if you install a high temperature alarm, this alarm will tell you the cooling water flow has stopped. It's clear. This is most important. And all of you people, who came and met me first, you people should say yes, then only I will go, because you are more interested people. Of course, others are also, but then mainly you people have shown interest in that. Please. The same way, for more flow, more cooling water flow, control all failure, operator fails to take action on alarm, too much cooling, reactor cool, instruct operators. Because if you want to have a reactor at a particular temperature, if you cool it too much, it will take a long time for the batch to be over. That is not desirable. You'll lose production, no? Like that. All these things are all recorded more, as well as more pressure in reactor, off-spec product. See, other than, so this is whatever is put in red, this is what is the outcome of the discussions of the group. The group will discuss and the members will say, no, if this happen, what can happen? No, they will say, no, that will be, the product will become off-spec. You should take care of that. Like that, this is the way this HAZOP goes further like that. So same way, shell and tube heat exchanger, this is very common in all our process industries. The same way, less flow of cooling water, pipe blockage, temperature of processing fluid remains high temperature alarm, even a high temperature alarm. If that alarm is there, it will tell you that there is a problem with the heat exchanger, that flow is not there. Okay, like that, more flow, temperature process decreases. So all these things, corrosion of tubes, So then hardness of cooling water, that is also a reason. Less cooling and crack of the tubes, proper maintenance. You have a cooling water treatment program by which your corrosion doesn't take place. Got the point? These are the things by which your whole HAZOP sheet will be able to guide you what controls you have, what controls you don't have, what controls you should adapt. This is the purpose of HAZOP. So that further it continues, like that. Failure of inlet cooling water valve. Install temperature indicator before and after the process fluid line. Install TAH, temperature alarm high. Like that, install temperature indicator before and after process fluid line. Okay. Proper maintenance of operator alert, contamination. Okay. These are the things, various ways that sheet is filled up, and the sheet action, which is that this one, it is finally taken up and implemented so that your safety improves further. Am I clear? This is the most important aspect of this HAZOP. That's all. Thank you very much.